In this topic, I would like to talk to you about Internet of Things. I'm sure I heard IoT for many times, and I would like to talk to you in more detail about it. So when you look at the standard IoT protocol, and typically on the right side is that this is a typical, not the Internet of Things, the typical protocol IPv4, IPv6, TCP, UDP, HTTP, DHCP, and TLS and SSL. All of this are, web stack typically, but when you look at the, left side, this is IoT stack. Here's an RIT application, and there's a binary, JSONs, and CBOR being used. And for the application layer, it's very different because this is all heavy, and the IoT not able to handle the heavy protocol. They have to come out with a new protocol. So that's why it came with COAP, MQTT, XMPP, and AMQP. Another thing is, way it is when you use the internet. Think about it. When you use the internet, most cases that you'll be using internet as a download, right? Down speed. You're watching a movie or you're watching a YouTube. You're receiving email, large email is mostly a download, and some course you are using upload, like sending emails, things like that. But when you typically is a download. But when you look at the IoT, it's mostly uploads. Getting a sensor information is upload into the cloud. So it's a different behavior. So therefore they have to come out with a different protocol, right? As for the transport layer, TCP is not readily being used because it tends to be slow. You have to wait for acknowledgement, right? So if there are so massive, IoT or sensors and devices, it doesn't really require to receive every single little bit. If it's not, other sensor will pick up the, information and send it. So you don't need to have a TCP. It depends on the application as well. And there's a low power person area network. And on this side, there's 802.15.4 MEC. And this is, it's for the, ZigBee types protocol. There's 84.4 physical, a different protocol. It's all in the 802 dot area, right? So because of the IoT protocol, and it applies in many, many different sectors, right? It applies in the automotive industry, in a health, telemedicine, home automation. When you apply it a different application, it used differently. So it's hard to, when you think about the, internet or, networking, in most companies, use internet for typically the same things, sending information. But when you talk about IoT, it's being used at a different industry. Is a scale is different. How it's being used is different. Also, the environment's different. So they need a cross-sector standards. So it's a one M2M architecture standard for machine-to-machine communication, and designed to apply many different industry. Okay, it's a machine-to-machine. They need to standardize it. One of the big problem is right now is that a lot of the machine-to-machine protocol is so proprietary. Microsoft make their own, and Google, they have their own proprietary protocol. So if you mix and match with the other companies too, it cannot communicate, right? So that is a big issue. So purpose of goal of one machine to machine is to develop technical specification which addresses need of a common service layer. It can be embedded into hardware and software, and basically it's a more of a general standard. It's used in many different places. Okay, so critical objective is to attract and actively involve organization from machine-to-machine related business such as a telematic, intelligent transport protocol, healthcare, utility, industry, automation, smartphone, and all of those being used, but it can be done, but using just the generic hardware and software embedded. I mean, service layer being embedded in the hardware and software. Okay. So there's other protocol organization is OCS, Open Connectivity. Open Connectivity Foundation is interoperable for consumer, business, industry by, delivering standard communication platform, in a open source. It's a standard. It doesn't matter what kind of business you have. It doesn't matter what kind of types of consumers you have. So communication-wise, it's being just a standard form, And so that is being able to standardize it, being able to communicate with different businesses, even with a different manufacturer of IoT devices, they'll be able to communicate because they're using a standard communication protocol. Okay, so there are a lot of different organizations, to help implement the IoT in their different industry. Okay, there's also organization like ITU, International Telecommunication Union, Smart Grid 20. It is IoT used for the smart grid. Remember, Jeju Island has a smart grid in there. So there's also IEEE architecture, framework, the Fuse block event, open fog, and there's a smart thing, a protocol, getting started. If this and that, that's easy to connect, plug in. There's Echo and the HomeKit. So there are a lot of products out there. But still with that, we have still lack of shortage of interoperability, and there are a lot of standard efforts is going on, and it's very challenging because people in healthcare, they're not really doesn't understand how IT function properly, and and also when you talk about the industrial IoT, they have a different role, so they're not from the IT company, right? So all of this IoT, the protocol has to communicate in non-IT companies' application and businesses, and it's still there are a lot of lacking in the standardization, a lot of interoperable issues, and you got to go with the one company. Okay. Characteristic of IoT is tends to be very dynamic, self-adapting, self-configuring. What I mean is that the IoT be able to communicate with one another. It can configure its own clusters. Interoperable communication protocol has a unique identity. It's a MAC protocol and integrated into information network seamlessly. Okay. For the design of IoT, and let's look at it in more detail. I go first to IoT devices. The IoT device can exchange data, collect data, send data, perform certain tasks, locally. So to do that, you gotta have this connectivity, the processor, and the audio and visual interface. It could be HDMI. There's a input-output interface for actuator. There's a storage interface, graphic interface, and memory interface. So these are the typical IoT devices out there. Okay. So one reason that I want to explain this is that when you talk about the IoT protocol, like you saw in the beginning of this presentation, it has its own unique characteristics. Okay, for the link layer, it does have Ethernet, Wi-Fi. There's additionally, wireless personal area network. You can interact with the 2G, 3G, 4G. And internet layer, transport layer, application layer, all of this have somewhat unique combination compared to the current non-IoT internets. Okay. So when you look at more of the application layer, there's a COAP. I'm going to talk to you about MQTT. So in a COAP, remember all the information, most of the information in IoT is upload, right? You're getting the sensor is being upload. It's a COAP is a customer client service to IoT protocol. It enables client to make a request, web transfer per needs for an hour. What it means is that if a customer needs some information, it can request it, it can get the information from the server. Okay. So because as a customer, you need a sensor information, right? You need a sensor information to do something about it. Those sensor information could be goes to the cloud, you process it, whatever the information that would be, you need that information, okay? So so you need to basically a request and you get that information. So COAP and HTTP follow the same working procedure. A COAP, attains a functionality by asynchronous. It's not asynchronous. It's just like a post get and delete call. The problem with that is the COAP is not really scalable. If one person wants to get that information, you can get it, right? But it's not really scalable. But it can be used. So there are 4 types of information: exchange, acknowledge, confirm message, message of reset message. All of this. I'm not going to go in detail about it. And one important protocol that I would like to mention is that MQTT. This is being really used widely. This is more of a scalable protocol. So once you collect the information from the sensor, let's say it goes to the cloud, right? It goes to the cloud, and the cloud performs the machine learning, or a cloud performs the storage, a cloud performs whatever it needs to do, it stores in there, okay? Then, like I said, COAP, if it needs the information, it goes to the cloud, get that information. That's more of the demand, right? And asynchronous on demand. But in this case, is if you subscribe to the certain information, MQTT will send it to you if you subscribe to certain information. Okay. So when you subscribe, it will send it to you. And this is more mass scalable. It can send it to you massively. It does not just the one person, there could be thousands, maybe 10,000 person. So within the server, you can send it out. Okay. So HTTP is too heavy, and there's no other comparison for the IoT devices. MQTT is the best protocol. So this MQTT is made for IoT. It's a lightweight machine-to-machine communication. They call it telemetering. It's invented by IBM. It's originate from what they call as a message queuing. It holds a message and you deliver to you when you need it. Okay. So it's a basic thing. It's very lightly. It's very scalable. Also, the Facebook Messenger uses MQTT to minimize battery usage. It's very scalable. It's open source implementation. Client brokers are available. It's because you can consider the cloud or whatever as a broker. Okay, so a lot of the subscriber comes to the broker for subscribe some information, some data, so it can deliver to them during their subscription. Okay. So typically is how it works. For example, temperature sensor, humidity sensor, light sensors all goes into the cloud somewhere. Okay, you can process it. You will combine temperature, humidity, and the light sensors combine. You can create a new information. Okay. After that, you will send it to whatever the information. Send it to the appropriate user. I mean, temperature information could apartment, building, the light sensor, you can send it to apartment dweller, all of that. But other information such as all the processed information, or what I mean is a calculated information or machine learned information. All of those information is can process it here and send it to the user. Right now is only two. You could have maybe a 10,000, maybe 1,000, 5,000, or 15,000, whatever. So it's a massive, it can very scalable solution. So this is more of a quality service level. If you send it, you don't know whether you receive. Once you get acknowledgement or something, then then you have to send it. So if it's not, you send it again. So retain message. If server keep messages even after sending it to all the subscriber to keep it. If the new subscriber comes in, and you'll get the retain information with what you mean is information that's already sent out to everybody. You'll get that information on demand when you first subscribe it. It's very clean and the durable connection. This is the most what do you call it? Popular protocol. And there's a periodic, it keeps alive message where the client is alive and message. And if the client is not alive, there's no continuing send it to that client, right? So typically, a sensor collects MQTT collects all the sensor information, okay, and a broker, and so MQTT information, and you process it in the cloud. The broker that connects to the server here, whatever the receiver subscribe, you will send that information to that subscriber, okay? I'm not saying there's a one broker. There could be a multiple broker. Broker can communicate with one another to minimize the duplications. If the receiver is not in this location, probably move to different location. It can deliver the subscribe information to the different location when needed. Okay. So the MQTT example is a home pacemaking monitoring solution. So, sensor on the patient, collect the monitoring equipment at home, something like this. And then you will collect the informations. You go to the internet, message over, you perform the analytical information, right? So what it does is you will send those information to the doctor as a subscriber. It could be one doctor, two doctor, or it could be one hospital, two hospital, whatever that, or relative or something. You can send it to a lot of different destination. Okay. So when you look at the comparison between MQTT and HTTP, I just want you to give some understanding of it. So HTTP is document centric, and the request response is more complex. It's pretty heavy when you think about it. You're sending a large file, large attachment, and it's only a one-to-one. So HTTP cannot really use it in an IoT setting. So when you look at the MQTT, it's more of a data centric. Remember, right? It's going up, getting the data going up, right? It's mainly works on a publish subscribe, a framework. It's simple, it's small. A lot of the data are very small. It's not big as like a file. So it's very different than HTTP, right? So data distribution is 1 to 0, 1 to 1, just like HTTP, but it's 1 to many, which makes it very, very scalable. Okay. So again, here's the IoT ecosystem and application, and MQTT, and 6 low person area network, data link. There's also the software, the operating systems, hardware. Those are the IoT ecosystem. I want you to know there are a lot. Okay, there are a lot of proprietary products out there. It's not usually using the its own its standardized version. Sometimes standardized version is not available, right? As you can see, software is a lot of it is a proprietary. So its problem is it's not able to interoperable with different product. That's the really a downside of it. Side of it. Okay. So that's the Internet of Thing lecture. Thanks for listening. I hope you can listen to the next presentation, which is a logical design of IoT. Okay. Okay. Let's see. Thank you.